In this demo, we will cover how TrueFoundry acts as a central control plane for your enterprise AI, enabling enterprises to build, deploy, and ship secure AI applications from prototype to production, all within your VPC. While doing that, TrueFoundry ensures that your developer speed is super high because everything is API driven, there's cost efficiency across the board, things can be shipped to production at high scale, and there is a proper governance that can be followed by the platform teams as well. TrueFoundry can sit on top of your existing stack, including your hyperscalers as well as your on-prem stack, and integrate with your CI/CD pipelines, monitoring, and other systems that you are already using, while bringing in additional layers of cost management, audit logging, and RBAC. It then opens to developers an internal AI platform that enables them to experiment across models, including large language models, and building and pre-training their own models, deploying models as well as agentic applications in production grade way with scalability, and ensuring that while doing that, there is a central governance that is imposed by the gateway layer. This all come together in an enterprise architecture that we see here, where gateway acts as the central piece to control access to multiple models, including your self-hosted LLMs as well as LLMs from different API providers. The gateway also enables things like semantic caching, fallback and retries, guardrails, and cost management. Any application that is built by a developer can be built and deployed using TrueFoundry, and the prompt and responses can be logged within your internal store. These prompt and responses can then be used for fine-tuning different LLMs using your own data. And finally, the fine-tuned models can be taken and deployed and served behind the same gateway, completing the entire GenAI stack. So in this demo, we will start with the demonstration of TrueFoundry deployment capabilities, followed by the governance capabilities around gateway, and finally, what are additional things we do to enable application templates for faster building. So let's dive right in. So if you see, this is the setup wherein you can bring your own clusters, including your cloud as well as on-prem environments. Once this setup is done, developers can start using the platform. We'll go into a deep dive of the overall infrastructure setup at the end. So let's start with the demonstration of deployment. So the deployment enables enterprises to actually take any model, including an LLM or any application, and deploy it as a real-time endpoint. So we'll click to no deployment. Let's take an example of a simple model deployment here, where you'll select a workspace depending on which team you are here. You can give it a get repo, a Docker image, or a code from laptop. For now, we'll take an example of a public Git repo, which is a emotion classification model. The system integrates with your GitHub and ensures that the latest Git commit SHA is pulled in. The system can then allow you to select the endpoints as configured by the platform teams, and you can impose custom security rules like JWT, auth, etc. here. You can also select resources including CPU and GPU, agnostic to cloud providers, and if the models are small, you can actually go for fractional GPUs as well. We do intelligence to allow you to run between spot and on-demand and ensure that there is high reliability as we switch across them, especially in dev and staging environments, which helps in lowering cost. Apart from this, the system has configurations for scaling in production using RPS. You can auto shut down and scale to 0 if there is no traffic to optimize for resource costs, and other production grade settings like rollouts, liveness probes, and so on. You can then deploy any service using a YAML configuration, or you can deploy it using UI or a Python. For now, I'll go ahead with the UI deployment. The system will start to create builds, and then it will kind of go ahead and deploy the system in the most optimal way. So I'm changing the name here. And as you see, the deployment will start to happen. Our system also kind of ensures that while you are building this, the build times are 3 to 10x faster than any other system. And as the deployment finally happens, you will get an endpoint that can be used as a fast API app. So this is an example of a fast API endpoint that is exposed as the deployment goes through. You can test it out for any application. Just like a simple model deployment or an application deployment, TrueFoundry also enables you to deploy any LLM or other larger models. So you again select the workspace, and you have options to kind of bring in any of the models, including vision language models and text-to-speech models. You can also give us any other Hugging Face model link and select the task that it corresponds to, and the system will figure out the best way to deploy it. For this, I'm taking an example of a Zephyr model. we see that it prompts me that VLLM is the right model server to deploy it. However, if you want to ensure the best performance, you can also go ahead with Tensor RTLLM. In this case, I'll go ahead with the configuration recommended. And the same form which was used for service deployment is now available, but it's auto-filled with the best settings. For example, it selects VLLM here. It automatically configures your CPU, memory, and storage requirements. We also go ahead and do additional things like caching to ensure better latency and faster auto scaling, and additional production grade settings. In order to deploy it, I'll follow the same mechanism and click submit, and it will go ahead and start deploying my large language model. In the interest of the demo, we'll see an example of an older LLM model that we deployed. So this is a DeepSeek model. As you see, it has multiple versions. The versions can be tracked here, and you can compare across versions and move to any older version. You also get to see complete logs and metrics for any model that you deploy, including metrics corresponding to GPU temperature, memory, etc. You can then go ahead and integrate it with your CI/CD pipeline and promote and move it to other environments in dev or staging or prod. Once a model is added, you have an ability to add this LLM to a gateway layer, and then you can go ahead and try it on the gateway. Before going there, let's cover a few more additional functionalities. As you deploy a model, we kind of ensure that the system is running in the most efficient way. So what we will do is, for any deployment, we will also give you recommendations if you have over provisioned or under provisioned. So for example, here you are seeing recommendations for cost optimization. You will see recommendations for reliability. We have recommendations for alerts as well that you will see in the system. And you can go ahead and look at the details of this alert within the system, and the insights will be recommended here. If you want this to automatically be applied, you can actually trigger Autopilot, and the system will go ahead and apply these recommendations for you and actually make the system running optimally. So what it does is, for any model, service, backend, or any application deployment or an LLM model deployment, it ensures that your system is running in the most optimal manner. And all these recommendations are then applied to your system, and you can go ahead and visualize it actually within your Access tab. So you can go into your settings, and you can look at all the audit logs corresponding to what has happened with Autopilot and how it has helped in improving the reliability of the system. Next, from here, let's go into the gateway. So we discussed about deploying an LLM. Now, if I want to access it and I want to try it out, I can actually add the models to this system. All the models can be configured here, including models from different cloud providers. I can add all my custom models that I have deployed here as well, and I can configure access controls and so on. Within this playground, I can then have the ability to actually test across different providers. For now, I'll kind of use the GPT-4, and I'll see the response of this. So here it's actually running the model, and then it's giving me a response. I have an ability to select prompts that I want to use when I'm passing a model, where I can pass it different prompt templates. I can select the different types of ML repo where my prompts respond, and the version of the prompts as well. I could also integrate tools if the model has tool calling facility. Then all the prompts and responses ultimately get logged into your central database, where you can actually view things, and you can fetch them via APIs in order to get more details. So what is the cost of the prompt, latency, input tokens, and so on. From here, you also have visibility into all the metrics of the system: your input tokens, output tokens, your latency across P99, P50, your requests per second, your time to first token, which is very important in case of LLMs, your inter-token latency, and activity of users as to who is consuming what tokens and what is the rate of errors and inference. You also have ability to customize this dashboard as per your requirements. Apart from this, you can also configure different configuration settings for rate limiting. If I want to kind of limit how much information is, how much requests I'm allowing for a particular user or a use case or a model or across an application, I can configure it completely, and it's fully config driven. I can configure fallbacks to my models to ensure more reliability. I can configure load balancing across multiple models. And finally, I can actually configure guardrails. Some of these are predefined, and then you can also add your own custom guardrails. So this ensures that there is a centralized place for entire observability and governance for any model that is being used in the gateway, with prompt management, with configurations for reliability and cost management as well. Finally, when you deploy any agent and build it, you will have, like, this is an example of an agent that does SQL workflow analysis using natural language queries. Any prompt and response that I pass to this agent is finally also been traced in the gateway, where I can actually see the tracing of the prompts, tracing of the entire queries within this of the agent within this. This configures the entire gateway. From here, now we will go into the LLM LLM build part. Now, once you have deployed an LLM model and you want to now fine tune and use your own fine tune models, Jobs allows you to fine tune different LLMs. So we'll take an example of deploying a fine tuning job. Just like we deployed a service, we have a fine tune LLM, which allows you to take any LLM and fine tune them according to your requirements. So I'll take one of the LLMs here and I'll go ahead and launch it. Again, we have different modes of fine tuning, and you can launch it as a notebook as well as a job. The notebook allows for faster experimentation, and job is when you are running it at large scale data sets. So I'll take an example of a job deployment, and here I can configure where I want my prompt responses to get stored. I can give it the file that I want to kind of use for training and production data, and it automatically figures out the best resources for running the fine tuning job. The hyperparameters can be customized as per the need, but we already exposed some of them right here. So once you submit, the system will go ahead and deploy this fine-tuning job, and you will be able to see that coming here. Once a fine-tuning job is deployed, you will be able to track all the metrics corresponding to the fine-tuning job in here. And you can run it from the UI or from your SDK directly. So I'll run it from the UI or even programmatically. And as you run, your fine-tuning job will be kicked off and it will start running behind the hood, and it will automatically shut down when it does so. One of the things we do is we also enable you to run this efficiently in your spot instances. And finally, when the job finishes, all your prompt responses, all your metrics get logged in, including across different epochs. The models corresponding to the fine-tuned jobs are also present here, and you can then go ahead and deploy this model in a similar way as you are deploying any other application or any other LLM. You also have all the artifacts and the checkpoints stored here. The models rely in this zone within model registry, and we offer automated way for deploying any of these models directly from the interface. Finally, we also have a concept of an application catalog, where you can not only deploy and fine-tune LLMs, but also deploy other things that are required for bringing the final application. For example, you might want to do benchmarking of LLMs, or you might want to deploy a RAG model. So we ask you to kind of just select one of the application templates, and this can be fully customized to your enterprise and can have many more application templates outside of this. And you can just go ahead, and it gives you a very quick way to then go and deploy this. So this is an example of a similar template for LLM benchmarking, where you give the different model endpoints and you can benchmark them as well. This, as we see, is a deployment of a RAG. And in an application set, you have all these components that come up together, and you can actually query the front end. So the front end you see here is an example of our RAG application. It can be fully customized as everything is API driven. But it gives you an ability to kind of set your collections, choose different models, set your prompt templates, and then run queries on top of this. You can create your collections here with different access controls. You can connect your different data sources, and you can bring in and connect different applications here. This allows you to bring up a RAG application from get-go at pretty much production grade, and you can use it to quickly test out applications and deploy it as well. Similarly, in case of fine-tuning, in case of benchmarking, we have the benchmark template, which spins up a LLM benchmarking job, and all the details of the benchmarking job get stored here, where you can actually then compare it and see what are the results of my benchmarking of LLMs. And all the benchmarking results then get stored in the model repo, where you can see what is my end-to-end latency across different models, what is my inter-token latency, and so on. All of this can also be governed by our LLM locus tools, which allows you to test the scalability of LLMs and do even more deeper benchmarking on LLMs. Finally, all of this is actually governed by our platform setup, as you see here, where you can come and connect multiple clusters, including your AWS, GCP, Azure, as well as your on-prem clusters. We give you insights on what is running on these clusters in terms of cost. We also get cost insights in terms of the last 7 days to 15 days. You can then integrate with your Git repos to enable a GitOps based policy. We can integrate with other services from cloud here. And finally, as a platform team, I can set up my policies where I can say that, okay, I want to auto shut down my GPUs and enable it in all my tenants. And these policies can be controlled from here by the platform team. And once it's set, it automatically enforced on the overall system. So if you see, this is my environment where this auto shutdown policy is enabled. And when I go to this environment, I'll see a lot of my apps which are actually in auto shutdown. So let's take an example of this app. It does not have any nodes running today. But when I go to this endpoint and I trigger a request, you will see that the node starts to come up. So this ensures that your auto shutdown policy is configured correctly. With this, we will end the demo of the platform and hope we look forward to kind of seeing how we can help you.